So good morning students, let us have a discussion on the in-text questions of chapter 12, that is electricity. So already we have seen some of these questions. The first question here, these are the in-text questions, okay, in between the chapters which are present. What does an electric circuit mean? So basically here the answer would be, you can find the same answer, same line on your NCERT book. Okay, a continuous and closed path along which an electric current flows is called an electric circuit. Question 2, we have defined the unit of current. So the answer would be, it is ampere. And how do we define this? We know that capital I, okay, current is equal to Q upon T. So if 1 coulomb of charge flows through any section of a conductor in 1 second, then the current through it is said to be 1 ampere. Okay, so 1 ampere basically is equal to 1 coulomb per second. Okay, flow of 1 coulomb of charge per second. Question 3, we have, calculate the number of electrons constituting 1 coulomb of charge. So we already know that charge on 1 electron is given as minus 1.6 into 10 to the power minus 19 coulomb. So this is the magnitude value, okay, the magnitude of the charge on electron. Now we already know that charge is quantized, that means it always mentioned as the integral multiple of this number, okay, of this magnitude, that is 1.6 into 10 to the power minus 19 coulomb. So it is given as Q is equal to N into E. So we can find out the value of N, okay, that is number of electrons, okay, present in 1 coulomb of charge or constituting 1 coulomb of charge. So you will get this value 1 coulomb upon this 1.6 into 10 to the power minus 19, and you get the answer as 6.25 into 10 to the power 18 electrons. Now next we have, name a device that helps to maintain a potential difference across a conductor. So the answer would be a battery or a cell. Now next question, what is meant by saying that the potential difference between 2 points is 1 volt? So the answer is, the potential difference between 2 points is said to be 1 volt, okay, if 1 joule of work is done in moving 1 coulomb of electric charge from one point to the another. Okay, so basically it is the amount of work done in moving a unit charge, okay, yes, fine, from one point to the other or between 2 points. Now question 3, we have, how much energy is given to each, okay, coulomb of charge passing through 6-volt battery? Fine. So here, how much energy is given by the battery to each coulomb of charge? So basically we know that, okay, work done is given by charge into the potential difference here, okay. So 6 volt basically is the voltage or the potential difference given here, okay, and the charge is 1 coulomb. Now energy will be equivalent to the work done, so the answer would be 6 joules. Now next question we have on page number 209, okay, that is, on what factors does the resistance of a conductor depend, or list the factors on which the resistance of a conductor in the shape of a wire depends. Okay, so here the answer would be, the resistance of a conductor depends on its length, on its area of cross section, and on the nature of its material. Okay, so this already we have seen, R is equal to rho L upon A, that formula also you can mention here. Next question we have, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source, and why? So the answer would be, the current will flow more easily through a thick wire than a thin wire of the same material. Okay, larger the area of cross section of a conductor, more is the ease with which the electrons can move through the conductor. Okay, therefore smaller is the resistance of the conductor. We already have seen resistance of any conductor is inversely proportional to the area of cross section. Okay, that means the current easily flows through a thick wire. Next, let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? Okay, so we already have seen Ohm's law, okay, and we know what it states, okay, V is directly proportional to I, okay, resistance हमारे यहाँ पे constant है, V is equal to IR, तो resistance आपका constant है, so that means what? That means here, if you half, okay, if you reduce the value of, okay, potential difference to half, then current will also be reduced to half. It is according to the Ohm's law. Next question we have, why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Or the same question can be asked in this, why are alloys commonly used in electric heating devices? Give reasons. Okay, so basically you might have seen, okay, the coils of electric toasters, electric irons and other heating devices, okay, they are always made up of alloy rather than a pure metal, because see, when we start heating using these electronic items which are heating devices, basically the coil in them, they become red hot, okay, they does not burn, okay, or they does not undergo oxidation even at very high temperature when it is red hot, fine. Secondly, these alloys, their resistivity is very high, okay, their resistivity is very high compared to the pure metal, so they have high resistivity, okay, and they does not undergo oxidation, so we use alloys. If you use pure metal, okay, इसकी जो रेसिस्टिविटी है वो कम होती है अलॉय से, दैट मीन्स इट अलाउज करंट टू फ्लो विद मच मोर ईज, okay. Secondly, they undergo oxidation at high temperature, fine. So to avoid all this, we are using alloys. Now next question we have, use the data in table 12.2 in NCERT book on page number 207 to answer the following questions, okay. So you can refer the data and you can answer the questions based on that. Which among iron and mercury is a better conductor, okay. So we can compare the resistivity of iron is given to be 10 into 10 to the power minus 8 ohm meter, whereas resistivity of mercury is given to be 94 into 10 to the power minus 8 ohm meter. So here we find the iron has a higher resistivity, okay. Sorry, what we find here is, mercury has a higher resistivity, okay. So higher resistivity means it obstructs the flow, whereas iron being having low resistivity, it easily allows the current to flow, so it is a better conductor, iron. Next, second one, which material is the best conductor? So among all the materials given in table 12.2, we find silver has the lowest resistivity. सबसे कम जो resistivity है वो silver की है, चांदी की है, okay, that is 1.60 into 10 to the power minus 8 ohm meter. So silver is the best conductor. Now next question on the page number 213, okay. The question is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor and a plug key, all connected in series. So यहाँ पे आपको एक circuit diagram draw करना है, okay. You can draw the diagram as shown in the figure, okay. ये series मतलब end to end connection है यहाँ पे, you can see here, draw in the same way. Now next question we have, question number 2. Redraw the circuit of question 1, okay, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and voltmeter? So reading in ammeter means, that means you have to find the current, and reading in voltmeter you have to find the potential difference, basically, okay. So now here you have to redraw that circuit. इसमें आपको क्या ऐड करना है, एक एमीटर ऐड करना है, दूसरा एक वोल्टमीटर, okay, to measure the potential difference across 12 ohm resistor. So you have to draw it in the same way, okay. यहाँ पे सिर्फ एक आपका एमीटर ऐड हो गया है, okay. This is also in series and this voltmeter will be in parallel to this 12 ohm resistor, okay. Yes. So यहाँ पे पहले तो आप you can find out the total resistance जो है आपको जो सीरीज़ में जो होता है, you have to add up all this, okay. Simply यहाँ पे वो ऐड कर देंगे, 5 plus 8 plus 12, totally it comes out to be 25 ohms. Total resistance are, वोल्टेज जो है आपकी दैट इज़ 6 वोल्ट, क्योंकि यहाँ पे जो बैटरी द बैटरी इज़ कंपोज ऑफ 3 सेल्स ऑफ 2 वोल्ट ईच, तो पूरा ऐड होके वो आपका 6 वोल्ट हो जाएगा. पोटेंशियल डिफरेंस इज़ 6 वोल्ट. रेसिस्टेंस आपको पता चल गया. यू कैन फाइंड द करंट, ओके. करंट जो है दैट यू कैन अप्लाई द ओम्स लॉ हियर एंड यू विल गेट वोल्टेज अपॉन रेसिस्टेंस दैट इज़ 0.24 एम्पियर. नाउ रीडिंग इन वोल्ट मीटर, दैट मीन्स यहाँ पे आपको अब वोल्टेज फाइंड करनी है, तो करंट आपको पता है क्या है, और रेसिस्टेंस जो है यहाँ पे आपको 12 ओम जो है लेना है, बिकॉज हमें सिर्फ 12 ओम के अक्रॉस ही पोटेंशियल डिफरेंस फाइंड करना है. सो द आंसर वुड बी 2.88 वोल्ट. यू कैन ट्राई दिस न्यूमेरिकल. नाउ पेज नंबर 216 वी हैव question number 1, judge the equivalent resistance when the following are connected in parallel. Okay, so 1 ohm and 106 ohm, these two are connected in parallel. Okay, so जो आपका equivalent resistance resistance होगा, how it will be. Secondly, if 1 ohm, 103 ohm and 106 ohm, they are connected in parallel, so what will be your resistance? So what we find, okay, when the resistances are connected in parallel, the equivalent resistance is smaller than the individual resistance. Okay, yes, first one, equivalent resistance is less than 1 ohm. Equivalent resistance is less than 1 ohm in both the cases. ओके, पैरेलल में है, कनेक्टेड है. ओके, पैरेलल में आप कैसे फाइंड करेंगे, 1 अपॉन में आपका आएगा 1/1 प्लस 1 अपॉन 106. सेम वे हियर 1/1 ओम प्लस 1/103 ओम प्लस 1/106 ओम. ओके, एंड इफ यू कैलकुलेट यू विल फाइंड आउट द इक्विवेलेंट रेजिस्टेंस इज मच स्मॉलर देन द smallest individual resistance. Okay, you can try this out, solve it. Next question we have here, an electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. Okay, so basically 3 electrical appliances are there with their resistances. Okay, they are connected in parallel to a 220 voltage source. Now what is the resistance of an electric iron connected to the same source that takes as much current as all the 3 appliances? And what is the current through it? So resistance of electric lamp, you can take it as R1 100 ohm. Okay, resistance of toaster, that is R2 50 ohm. Water filter resistance R3, that is 500 ohm. Now इक्विवेलेंट रेजिस्टेंस जो है टोटल पैरेलल में है ये 3 अप्लायंसेस, तो क्या आएगा इनका, इट विल बी 1 अपॉन में आप कर सकते हैं 1/RP 1/R1 प्लस 1/R2 प्लस 1/R3. द आंसर कम्स आउट टू बी 31.25 ohm. सो दी रेजिस्टेंस ऑफ इलेक्ट्रिक आयरन. ओके, यस, जो इलेक्ट्रिक आयरन है आपकी, इट इज़ कनेक्टेड टू द सेम सोर्स. ठीक है, सेम करंट जो है वो ले रहे हैं एज द 3 अप्लायंसेस आर टेकिंग. So current through that would be, actually it will divide basically. Okay, so resistance electric iron का जो it will be equivalent resistance of the 3 appliances connected in parallel. resistance जो है हमारा वो इतना ही रहेगा आपका यहाँ पे. ठीक है, 31.25 क्योंकि all are connected in parallel. voltage जो है वो divide नहीं होगी, वो same रहती है in parallel. Okay, connection. So 220 voltage current you can find out. Okay, you will get the answer. Now question 3 we have, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? So there are some advantages actually if you connect the electrical devices in parallel with the battery. Okay, yes, so if due to any defect, if one electrical appliance stops working, the other appliances they keep on working smoothly normally. Okay, this is the major benefit of connecting the electrical appliances in parallel. Usually हम लोग घरों में जो है parallel connection ही follow करते हैं. Next, in parallel circuits, each electrical appliance has its own switch due to which it can be turned on, okay, turned off independently without affecting the other appliances. तो यहाँ पे we can control the functioning of each appliance, ठीक है, without affecting the other appliances. Apart from this, each electrical appliance, okay, they get the same voltage as that of the power supply. इनमें voltage divide नहीं होती है, potential difference same रहता है. Okay, so in the parallel connection of electrical appliances, the overall resistance of the household circuits is reduced due to which the current from the power supply is high. Okay, तो यहाँ पे जो है these 4 points we can write down. Next question we have, how can 3 resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? So basically total resistance of 4 ohm, okay, by connecting the 2 ohm resistance in series with the parallel combination of 3 ohm and 6 ohm. So if you do this, okay, you will find out that the equivalent resistance would be 4 ohm. Now secondly, how to obtain 1 ohm? So for this, you have to connect the resistors of 2 ohm, 3 ohm and 6 ohm in parallel. So if you connect all these in parallel, you will get the answer as 1 ohm. Now what is the highest and the lowest total resistance that can be secured by combination of 4 coils of resistance, 4 ohm, 8 ohm, 12 ohm and 24 ohm? So highest resistance and the lowest total resistance we have to find out. So highest of course will be obtained when they are connected in series, and lowest would be of course when they are connected in parallel. Okay, so highest will be 48 ohm and lowest will be 2 ohm. Now here, so we'll wind up here. Okay, next questions we will discuss tomorrow.